Okay, hi everyone, welcome back to the Comptia Security Plus course, Software Development Lifecycle. To properly develop a secure application, the developer has to scrutinize it at every turn and from every angle. Throughout the life of the project over time, this idea manifested itself into the concept known as the Software Development Lifecycle (SDLC), an organized process of planning, developing, testing, deploying, and maintaining systems and applications, and the various methodologies used to do so. A common SDLC model used by companies is the waterfall model. Using this model, the SDLC is broken down into several sequential phases. Here's an example of an SDLC's phases based on the waterfall model. Planning and analysis, goals are determined, needs are assessed, and high-level planning is accomplished. Software systems design, the design of the system or application is defined and diagrammed in detail. Implementation, the code for the project is written. Testing, the system or application is checked thoroughly in a testing environment. Integration, if multiple systems are involved, the application should be tested in conjunction with those systems. Deployment, the system or application is put into production and is now available to end users. Maintenance, software is monitored and updated throughout the rest of its life cycle. If there are many versions and configurations, version control is implemented to keep everything organized. This is a basic example of the phases in an SDLC methodology. This one actually builds on the original waterfall model, but it is quite similar. However, it could be more or less complicated depending on the number of systems, the project goals, and the organization involved. While variations of the waterfall model are commonplace, an organization might opt to use a different model, such as the V-shaped model, which stresses more testing, or rapid application deployment RAD, which puts more emphasis on process and less emphasis on planning. Then there is the agile model, which breaks work into small increments and is designed to be more adaptive to change. The agile model has become more and more popular since 2001. It focuses on customer satisfaction, cooperation between developers and business people, face-to-face conversation, simplicity, and quick adjustments to change. The increasing popularity of the agile model led to DevOps and subsequently the practice of secure DevOps. DevOps is the post-Martin II of the terms of software development and information technology operations. It emphasizes the collaboration of those two departments so that the coding, testing, and releasing of software can happen more efficiently and hopefully more securely. DevOps is similar to continuous delivery, which focuses on automation and quick execution, but from an organizational standpoint is broader and supports greater collaboration. A secure DevOps environment should include the following concepts: secure provisioning and developing of software, services and infrastructure, secure automation, continuous integration, baselining, infrastructure as code, and immutable systems. Immutable means unchanging over time. From a systems and infrastructure viewpoint, it means that software and services are replaced instead of being changed. Rapid, efficient deployment of new applications is at the core of DevOps, and it is one of the main tasks of all groups involved. Core SDLC and DevOps principles. The terms and models discussed in the previous section can be confusing at times because they are similar, because there are grey areas between them that overlap. So if you are ever confused while working in the field, it's good to think back to the core fundamentals of security from a larger perspective. A programmer, systems developer, and the security administrator should always keep the CIA concept in mind. Maintaining confidentiality, only allowing users access to data to which they have permission. preserving integrity, ensuring data is not tampered with or altered, protecting availability, ensuring systems and data are accessible to authorized users when necessary. The CIA concepts are important when doing a secure code review, which can be defined as an in-depth code inspection procedure. It is often included by organizations as part of the testing phase of the SDLC, but is usually conducted before other tests such as fuzzing or penetration tests. In general, quality assurance policies and procedures should be implemented while developing and testing code. This will vary from one organization to the next, but generally includes procedures that have been developed by a team, a set of checks and balances, and a large amount of documentation. By checking the documentation within a project, a developer can save a lot of time while keeping the project more secure. From a larger perspective, an organization might implement modeling as part of its software quality assurance program. By modeling or simulating a system or application, it can be tested, verified, validated, and finally accredited as acceptable for a specific purpose. One secure and structured approach that organizations take is called threat modeling. Threat modeling enables you to prioritize threats to an application based on their potential impact. The modeling process includes identifying assets to the system or application, uncovering vulnerabilities, identifying threats, documenting threats, and rating those threats according to their potential impact. The more risk, the higher the rating. Threat modeling is often incorporated into the SDLC during the design, testing, and deployment phases. Some other very important security principles that should be incorporated into SDLC include principle of least privilege. Applications should be coded and run in such a way as to maintain the principle of least privilege. Users should only have access to what they need. Processes should run with only the bare minimum access needed to complete their functions. However, this can be coupled with separation of privilege, where access to objects depends on more than one condition, for example, authentication plus an encrypted key. Principle of defense in depth. The more security controls, the better. The layering of defense in secure coding may take the form of validation, encryption, auditing, special authentication techniques, and so on. Applications should never trust user input. Input should be validated carefully. Minimize the attack surface. Every additional feature that a programmer adds to an application increases the size of the attack surface and increase risk. Unnecessary functions should be removed, and necessary functions should require authorization. Establish secure defaults. Out-of-the-box offerings should be as secure as possible. If possible, user password complexity and password aging default policies should be configured by the programmer, not the user. Permissions should default to no access and should be granted only as they are needed. Provide for authenticity and integrity. For example, when deploying applications and script, use code signing in the form of a cryptographic hash with verifiable checksum for validation. A digital signature will verify the author and or the version of the code, that is, if the corresponding private key is secured properly. Fail securely. At times, applications will fail. How they fail determines their security. Failure exceptions might show the programming language that was used to build the application, or worse, lead to access holes. Error handling, exception handling code should be checked thoroughly so that malicious users can find out any additional information about the system. These error handling methods are sometimes referred to technically as pseudocodes. For example, to handle a program exception, a properly written pseudocode will basically state in spoken English, if a program module crashes, then restart the program module. fix security issues correctly. Once found, security vulnerabilities should be thoroughly tested, documented and understood. Patches should be developed to fix a problem, but not cause other issues or application regression. There are some other concepts to consider. First is obfuscation, which is the complicating of source code to make it more difficult for people to understand. This is done to conceal its purpose in order to prevent tampering or reverse engineering. It is an example of security through obscurity. Other examples of security through obscurity include code camouflaging and steganography, both of which might be used to hide the true code being used. Another important concept is code checking, which involves limiting the reuse of code so that which has been approved for use and removing dead code. It's also vital to incorporate good memory management techniques. Finally, be very careful when using third-party libraries and software development kits, SDKs, and test them thoroughly before using them within a live application. For the Security Plus exam, the most important of the SDL phases are maintenance and testing. In the maintenance phase, which doesn't end until the software is removed from all computers, an application needs to be updated accordingly, corrected when it fails, and constantly monitored. In the testing phase, a programmer or team of programmers and other employees checks for bugs and errors in a variety of ways. It's imperative that you know some of the vulnerabilities and attacks to a system or application and how to fix them and protect against them. The best way to prevent these attacks is to test and review code. Programming testing methods. Let's discuss the testing methods and techniques that can be implemented to seek out programming vulnerabilities and help prevent attacks from happening. Programmers have various ways to test their code, including system testing, input validating and fuzzing. By using a combination of these testing techniques during the testing phase of the SDLC, there is a much higher probability of a secure application at the end result. So I'll discuss the rest of this in my next video, but I'm going to leave it here today for this video. So if you like listening, please consider like, sharing and subscribing. Thank you.